f of x equals quantity x plus 3 squared plus 1. So let's figure out what the parent function is. If you look at that, the parent function, the simplest version of this, is y equals x squared, or f of x means y. F of x equals x squared. So it's an x squared type of graph. It'll be a parabola, sort of U shape. The plus 3 inside the grouping symbols, inside the parentheses, your rules say that shifts it 3 left. The plus 1 at the end shifts your graph 1 up. So lightly in pencil, you want to draw your parent function. You could just copy from the XY chart you had for your very first graph of y equals x squared on the front page. And then you're going to shift it 3 left and 1 up. Every single point, 3 left and 1 up. And that's your graph of f of x equals quantity x plus 3 squared plus 1. Now, graphing something with a negative coefficient, y equals negative x squared plus 5, it's still a parabola. It's still in the y equals x squared function family. A negative coefficient at the very beginning reflects your parabola over the x-axis. And then the plus 5 at the end, outside of grouping symbols, moves that graph 5 up. And that's your final graph. The last thing to talk about is just practicing applying this to a function family that's not quadratic, not y equals x squared. The absolute value function family. This is another that you may have been introduced to in Algebra 1, but if it's near the end of the book so the teacher ran out of time, this might be your first time seeing how to graph it. Now, if you have something like y equals absolute value of x, put that in an xy chart to plot some points. Absolute values are really asking what is the distance of this number from 0 on a number line. Negative 2 is 2 away from 0 on a number line. So basically absolute values signs get rid of negative signs and make all your numbers positive. If you graph that, you get that a y equals absolute value of x graph is a V shape. It's not a U shape like a parabola. It's very flat, straight ray pieces. So knowing that the parent function looks like a V that starts at the origin is going to help you graph problems like number 3. You know the parent function starts at the origin and makes a V shape. That negative 5 inside the absolute value, inside those grouping symbols, will shift everything 5 right. And that is your final graph. Pause here and try question 4 on your own. Check your answer on question 4. Now, sometimes you'll be asked to work backwards. Sometimes they'll give you a graph, and your job is to figure out what the equation of the new graph is. So here we have the graph of the parent function y equals x squared, a parabola in blue, and then here's the new version in red. We need to figure out how much the parent function was shifted to get the new one in red so that we can have the formula. If you look at where h of x's vertex is, where it starts, it shifted 2 left and 3 down from where it was in the parent function at the origin. And we could tell from the U parabola shape that the parent function was f of x equals x squared, or y equals x squared. It means the same thing. So if we use our rules and work backwards, shifting 2 left would be a positive constant inside the grouping symbols. Shifting 3 down would be a minus 3 at the very end of our formula. Pause here and try number 6 on your own. So here you could see that your parent function is a v shape, so it's an absolute value. And you can see how the red one is flipped upside down, it's reflected, and it's also shifted 3 left and 1 down. So based off of those notes, we can reverse engineer what the formula for the red one must have been. It's going to have absolute value symbols in it. It's going to have a coefficient at the very beginning of negative, a negative in front of the whole equation because it got flipped over the x-axis upside down. And then it got shifted 3 left, so that's a +3 inside the grouping symbols, and 1 down, that's a -1 at the end. And that's it for today, guys. Go ahead and turn in your notes